Hello dear learners, when you are attending a maths lesson with me, get ready with your book, pen and calculator. In the last lesson of calculus, we learned how to sketch the graph and we also did an exam question on that. This lesson is basically based on application calculus, but we are going to do one thing that we couldn't do in the last lesson, which is the equation of the tangent. So I found one question, to a simple one, to do it quickly, then we are going to application of calculus. Okay, so here you are given that fx equal to x square minus 8, and your first question is to calculate f negative 3. That is not a big issue. If you have fx equal to x square minus 8, then f negative 3 is just replacing the x by negative 3. So it's going to be negative 3 square minus 8, which will be 9 minus 8, 1. Now in 17.1.2, this was 1. In 2, you are asked to find f prime negative 3. That means you are substituting x equal to negative 3 in f prime x. So first calculate f prime x before we find f prime negative 3. So f prime x using the rule here is 2x, that's all, because derivative of the constant is 0. Now we are going to substitute f x equal to negative 3. So it's going to be f prime negative 3 is 2 times negative 3, which is negative 6. So that was just 1 mark questions there. Now 17.1.3 is determine the equation of the tangent. This is what I wanted to explain to you. The equation of any tangent. Tangent is a line that touches the graph at one point. Straight line like this. Suppose the point of contact where the tangent touches the graph is xt, yt, then the tangent is a straight line. Any straight line has equation y equal to mx plus c. So this is the equation of a tangent also. That means to find the equation of the tangent, we need the gradient and the y-intercept. But gradient, that is the important part here. Gradient of the tangent is found in this way. This is the derivative of the function. That is what we learned when we learned the derivative of a function. The derivative is also the gradient of the function at any point, or gradient of the tangent. But here when we take the gradient, you take the gradient at that point of contact. So gradient of the tangent is f prime xt, where xt is the point of contact. Now, so that's how we find the gradient. Now you must also find the y-intercept. To find the y-intercept, you substitute one point on the equation. So that one point is this point xt, yt. That means before we go to the equation of the graph, you also need that point yt. So if xt, it's already given in the question. The question was asking you to find the equation of the tangent at x equal to minus 3. That means in this case xt equal to minus 3. We don't have yt, so let's find yt. Xt here is minus 3. Yt is found by simply substituting xt in the function. Function is x square minus 8, so substitute x equal to minus 3. Minus 3 square minus 8, which is 1. But we already have it. That's why it only has 2 marks, because you already found what is f minus 3, that is 1. So here the xt yt is minus 3, 1. So we already have that point. The xt yt is minus 3 and 1. Okay, let's Now let's start with the gradient. Gradient is f prime xt, as I told you, but in this case f prime negative 3, because that is the xt here, and we already found it in number 2. F prime negative 3 is negative 6. So the gradient of the line, the tangent, is negative 6. So the equation of the tangent can be written as y equal to negative 6x plus c. So only c is remaining now. To find c, you substitute the only one point, which is xt yt in the equation. So yt is 1 now, 1 equal to negative 6 times negative 3 plus c. Therefore, c equal to 1 minus 9, which is negative, no, not 9, sorry, 1 minus 18, so it's negative 70. Therefore, the equation of the tangent is y equal to negative 6x minus 70. That is the equation of the tangent. Okay, that is all in calculus. Now we can go to a question on application of calculus. Okay, now we are going to application of calculus. Before we go to this exam questions that is given in here, let me go in general. In order to maximize or minimize a function, let me say for example ax, first determine the derivative and equate it to 0 and solve for x. This is a method that we are following in all application of calculus questions. Let's go to this question now. You can see it's a measurement question that you have done in grade 11, but here we are going to do it in application of calculus. A 350 ml can of cool drink with height h and radius r is shown below. Determine the height of the can in terms of the radius r. That is the question. 3 marks. So remember, always the given information is very important. A 350 ml can of cold drink means 350 ml represents the volume of the can. So now you can also see this is an exam question. The formulae are not given here. You must know the cylinder formula by, you must know it by heart, otherwise you won't be able to do problems on this. So here for a cylinder, volume is pi r square h, and total surface area of a cylinder is 2 pi r square plus 2 pi rh. You can't complete the question if you don't know these two formulae, and it will not be given in the question paper. So you have to know that. Now, given that, so we are doing 6.1 now. Given that volume is 340 ml, which is pi r square h equal to 340. Therefore, you are asked to find the height h in terms of r. So you divide both sides by pi r square, then you will get height equal to 340 divided by pi r square. That is height in terms of r. This is the answer for 6.1. So here the mark is for knowing the formula, equating it to 340 and finding the height in terms of r. Okay, now 6.2. Show that the surface area of the can be written as SA equal to 2 pi r square plus 680 over r. So that also you can do only if you know the formula for surface area. We know surface area is 2 pi r square plus 2 pi r h, 2 pi r h. But just now we found what is h, so we are going to substitute the value of h here. 2 pi r square plus 2 pi r, h is 340 over pi r square. Now the pi cancels here, r also cancels one of them, so one r will remain. So what is remaining here is 2 pi r square plus 2 times 340 is 680. In the denominator you are left with 1 r. That is what you were asked to show that. So we are done with the 6.2 also. Now we are going to the real calculus question, that is 6.3. Determine the radius of the can in centimeter if the surface area of the can has to be as small as possible. So when I was writing these notes here, that in order to maximize or minimize, so here all the questions, application of questions are either maximizing or minimizing, but the word maximize or minimize may not be there. For example, in this question, the area has to be as small as possible, so it's actually in the place of minimum. So you need to understand those words that they can use in the examination. They can directly say minimum or maximum. Some questions say that, or sometimes they say smallest or biggest. That is also maximum or minimum. Or some questions will say at least, or at most. Then also I have seen questions with closest or farthest. Okay, these are the words that they can use in the problem. So then all this means minimum or maximum. So here what should be minimum here? As small as possible, the surface area. So in all cases of minimum or maximum, you substitute the derivative equal to 0. That means SA, derivative of SA must be equal to 0. In this case, surface area, derivative of the surface area must be equal to 0. That means let's take the derivative of the surface area here, but this is not ready to differentiate as the r is in the denominator. So you can write the surface area once more to change it into the way it should be derivative. You can differentiate only if it's written in the form kx to the power n. So you have to change every function in this form before you differentiate. So here it's going to be 680 times r to the power -1. Now we can find the derivative. So the derivative is 4 pi r minus 680 r to the power -2. I hope you understand, because we did the differentiation using rules in the first part of calculus. So -1 comes here. -1 times 680 is -680, and -1 minus 1, -2, equal to 0. This is 4 pi r equal to 680 over r square. You can change it back to over r square, which is going to be, now I'm going to cross multiply. That will give you 4 pi r cube equal to 680. Now divide by 4 pi, that will give you r cube equal to 680 over 4 pi. Therefore r equal to cube root of 680 over 4 pi. The answer is going to be 3,78. That is R. So you are asked to find the determine radius of the can. So that is the answer. Radius of the can is 3,78 centimeter. So this is one type of application of calculus. Now we are going to see another question on application of calculus. Let me find another one. Okay. Let's go to question 3. A petrol tank at BP depot has both the inlet and outlet pipes which are used to control the amount of petrol it contains. The depth of the tank is given by dt equal to 6 plus t square over 4 minus t cube over 8, where d is in meters and t is in hours that are measured from 9 o'clock. Okay, question is 3.1.1. Determine the rate at which the depth is changing at 12. So from 9 to 12, 3 hours. And then tell whether there is an increase or decrease in depth. Answer correct to 2 decimal digits. That is the question. Okay, let's see. Here rate. This is the important part here. The rate at which. So this is the important part here, rate. Rate is also derivative. Rate is derivative, gradient is derivative. So when the question says rate, you are finding the derivative of the given function. So here the function is already ready to differentiate. These are constants in the denominator, so you can differentiate directly. Okay, 3.1.1. d prime t equal to derivative 6 is 0. For t square it's 2t over 4 minus 3t square over 8. 8, this 4 and 8 are constants here, so that is actually t over 2 when you simplify, minus 3t square over 8. Now we are not just finding the rate at which the depth is changing at 12. That means you are asked to find d prime 3 hours. After 3 hours, what is the depth of the tank? So you substitute t equal to 3. 3 over 2 minus 3 times 3 square over 8. Put this in the calculator, you will get negative 15 over 8, but the question says answer correct to 2 decimal digits, so you must write the answer in 2 decimal digits, negative 1,88 meters per hour, because it's a change in the depth, so it's meter per hour. We are writing a rate here, so you have to include the unit. Okay, now they are also asking us, and then tell whether there is an increase or decrease in depth. The negative tells us that there is a decrease in depth, so you can say a decrease in depth. Okay, that is 3 marks. Now 3.1.2, at what time will the inflow of petrol be the same as the outflow? Okay, inflow is increase in the depth, outflow is decrease in the depth. So now when the inflow and outflow are same, that means neither increasing nor decreasing. So this is a cubic function, so neither decreasing nor increasing means that is all about the turning points. Okay, this function is not the positive one anyway. It's actually this function, if you draw it looks like this. Now when it says inflow and outflow are same, that means turning points. So at the turning point, derivative is equal to 0. So that is a statement we are going to use in this question. 3.1.2 derivative equal to 0. That means d prime t is now equal to 0, but we already calculated d prime t, so it's t over 2 minus 3t square over 8 equal to 0. Let us simplify. Equating each factor to 0 will give you t equal to 0 or half minus 3 over 8t equal to 0. That is half equal to 3 over 8t. You multiply by 8 over 3 or you divide by 3 over 8, you get t equal to 4 over 3. So at time t equal to 0 and t equal to 4 over 3 means at 9 o'clock, because the whole thing happens at 9 o'clock. Where d is in meters and t is in hours, that are measured from 9 o'clock. So t equal to 0 means 9 o'clock. T equal to 4 over 3 means after 4 over 3 hours. So when you change it into minutes, you get 4 over 3 times 60. So you can write the final answer as at 9 hours and at 4 over 3 times 60, that is after 80 minutes later, which is going to be 80 minutes means after from 9 to 80 minutes later means at 10:20, 10 hours 20 minutes. This is the answer now to that question. Let's go to another question now. Question 9. A stone is thrown vertically upwards. Its height in meters above the ground at time t in seconds is given by ht equal to negative 2t square plus 12t plus 32. So this is a height and it's in meters, and the time is given in seconds. Determine the initial height of the stone above the ground. So that means initial height is when t equal to 0. So in 9.1, what we are finding is h0. So when you give t equal to 0, you got 32 meters. That is height when t equal to 0. That is the initial height. Now 9.2, determine the time taken to reach maximum height. So look at the word maximum now. So whenever you are doing any problem on maximum or minimum, the derivative equal to 0. That means here h prime t equal to 0. Now let's take the derivative of this function, which is going to be negative 4t plus 12 equal to 0. That means negative 4t equal to negative 12 or t equal to 3. So that's the answer for 9.2, t equal to 3. T equal to 3 seconds. Now 9.3, how fast was the stone traveling when it hit the ground? 5 marks. So how fast means we are finding we are finding the speed, actually how fast the stone was traveling when it hit the ground. Hitting the ground means height is 0. So we must first find when does the height become 0. Okay, let me write here so that we can also see the question there. 9.3, when the height 0 means ht becomes 0. When? What time? Let's find the time when ht is 0. So ht, the function is given as negative 2t square plus 12t plus 32 equal to 0. If you divide throughout by negative 2, you will get t square minus 6t minus 16 equal to 0. which is t minus 8 times t plus 2 equal to 0, factorizing. So the two values of t are t equal to 8 seconds or t equal to negative 2 seconds, which is not possible. So that is not an answer here. So here the answer is after 8 seconds. 8 seconds the stone hit the ground. But the question is not that, not asking you to find that time when the stone hitting the ground. The question is how fast the stone was. Okay, then for finding how fast, that means you are finding the rate of change of distance, which is actually the speed. So that is the rate of change, which is h prime t. So let's find h prime t before you substitute t equal to 8 there. So h prime t is negative 4t plus 2. Okay, we already found it somewhere. All what we are doing now is you give a t equal to 8 there. So it's negative 4 times 8 plus 12, which will give you negative 20, because it's the rate of change meter per seconds. Now the negative actually shows the stone is going downwards. That is the meaning of it. So how fast the stone was, that was 20 meter per second. The negatives just shows that it's going downwards. Okay, now that was 9.3. Now determine the acceleration of this stone. Acceleration is again rate of change of speed or velocity. So acceleration is the second derivative of ht. Rate of change of speed, so it's a derivative of h prime t, so it becomes a second derivative. You just has to find the acceleration of the stone. So the answer is 9.4. Okay, 9.4 is the second derivative, that is h 2 prime t. So this is h prime t, h2 prime will be negative 4. Nothing else to do, that's why it only has 2 marks, but meter per second square, that is the acceleration. So that also shows that it's going downwards. Negative shows that it's going downwards. That's all that we are doing on application calculus. I think we covered almost all different types of application of calculus questions that can come in the grade 12 examination. If you understand, please like the video, share, and also subscribe. Thank you very much.